Okay, what we're going to do today is look at solving problems using Pythagoras. Um, so the key to this is always draw yourself a diagram or a sketch. Okay, if it's just a worded problem on its own, a bit like example 2 down here, there's no diagram. Try and draw yourself a diagram. When we get there, I'll show you how. Okay, so let's have a look at example 1 first. So ABC is an isosceles triangle. Calculate the perpendicular height to two significant figures. Right, what you don't know, because it's not in there, is which side is equal to which side. So actually, it's these two sides, AB and BC, that are equal to each other. But it's not necessarily a right-angled triangle. So what they want to know is the perpendicular height. So the height of this triangle is going to be the distance from B all the way down to the line AC. So what you can do is perpendicular means at right angles. Okay, so perpendicular, that's going to be a line coming down that's going to make a right angle with the line at the bottom, and I'll draw a little square in there. So there you go, that's your diagram, and look, we now have a right angle triangle. Okay, and we can use that right angle triangle and Pythagoras to work out the height, the distance from B to this right angle of this triangle. Now let's have a look at the little triangle on the right hand side, the one where I put the little square, because I've got one side length, which is great, that's 8 centimeters, but this side length here I don't have. I do have this whole length. And what I know about, when I drop a perpendicular from an isosceles triangle, it splits this length in half. So 12 divided by 2 is equal to 6. So therefore this bottom bit is 6 centimeters. So now I have my two side lengths of a right angle triangle. So let's label our sides. The one opposite the right angle is always C, and then I've got A and B left over. So I'm trying to find out what B is. That's the height of the triangle. So let's write out Pythagoras, which is C squared equals A squared plus B squared. C is equal to 8, so that's 8 squared. A is equal to 6, so that's 6 squared. I'm not sure what B is, so that's the one we're trying to find. Right, let's square everything that we can square. So 8 times 8 is 64. 6 times 6 is 36. And then I've got plus B squared. Now what I want to do is rearrange this to get B squared and then square root that answer. So I'm going to take away 36 from both sides, because then that will get rid of this plus 36. So 64 take away 36 is 28, and that's equal to B squared. Now 28 is not a square number, so I'm going to have to use my calculator, because what I need to do next is square root both sides. So using your calculator, I've got the square root of 28 equals 2 root 7. Press the SD button, and that turns it to 5.2915. And they've asked for it to be two significant figures. So let's just write the first few down, 5.2915. The question is to two significant figures. So the 5 is the first one, the 2 is the second one. So I'm going to chop it off at the 2, but the 9 tells me to round it up or to leave it alone. And because it's a 9, I round it up to 5.3. And that's centimeters. And that's the perpendicular height. So the key there was to work out where the right angle triangle was, figure out what the lengths were on each triangle, on each side. I know that this side length is going to be half of this base because it's an isosceles triangle, okay? And I was dropping a perpendicular. Okay, and then all I had to do was work through Pythagoras theorem, which we've done a few times now, and then I had to round it to two significant figures. So let's have a look at example 2. This time they don't give me a diagram, so it's a wordy one really. A boat leaves point X and sails 5 kilometers due north. It then sails 7 kilometers due west to arrive at point Y. Calculate the distance from X to Y to one decimal place. That's a 1, by the way. So draw a diagram. So let's say it leaves at point X. Okay, this is the point at which it leaves. Let's make it a bit bigger. It sails 5 kilometers due north. Well, north will be up. Okay, so we'll say that north is up. Let's say it travels to there, and that is 5 kilometers. Then it sails 7 kilometers due west. So I don't know if you remember, but it goes north, east, south, west if we were to go rotational. And I remembered that as never eat shredded wheat. Okay, so north, east, south, west, never eat shredded wheat. So I need to go west, so I'm going to turn left, and I'm going to go all the way to point Y, and it says I travel 7 kilometers due west, so 7 kilometers. Now, whenever you turn to one of these angles, north to east, east to south, south to west, west to north, or north to west, or the other way around, you make an absolutely 90-degree angle. Okay, so that means it's a right angle. And if I were to join X to Y, I now have myself a right-angled triangle. And I can use Pythagoras on my right-angled triangle. Right, C is opposite the right angle, so this is C. And then A and B are the other two sides. So if I'm to write out Pythagoras, C squared equals A squared plus B squared. Then I substitute in the values I've got. I've got A and B. So C squared equals 5 squared plus 7 squared. Square those numbers. C squared equals 25 plus 49. And then add them together. C squared equals 74. I then need to square root those answers. Remember, I don't want C squared, I want C. So square root 74. Square root 74 equals, well, yeah, we know that, SD button, 8.6023. Right, and where did they want it to be? They wanted it to be to one decimal place. So, first decimal place is the 6, the next numbers are 0, so I chop off the 0, the 2 and the 3, and because it's a 0, I leave it alone. So, xy, the distance, equals 8.6 kilometers. Right, the trick with these questions is work out where that right angle triangle is, label your sides, and then go through the Pythagoras, okay? So you might want to go back and just do a couple more examples on that if you've forgotten, all right? Have a go at the worksheet, do your best, answers are there, but don't go straight to the answers, and I'll see you soon. All right, take care.